Hello guys, so today in this video we are going to discuss about histogram and types of skewness. So first let us start with histogram. So first I will write the definition of histogram. Histogram is a graphical way of representation of of the spread of the data so that means using histograms we can visualize the data about how the data is being spreaded in the given data set, so that we can easily find out by seeing the histogram itself whether what is going to be the mean, what is going to be median, and what is going to be mode. That means if both all the three, mean, mode, and median, could be equal or not, or else whether median is greater than mode or not, or else whether mean is greater than mode or not. So these kind of scenarios we can easily find by seeing the histogram itself. So for this we can use histogram even further to visualize the data and understand how the data is spread among the data set. So let us take an example of few data. Let me take some data. X is equal to 1, 2, 4, 7, 9, 11, 15, 21, 22, 25, and then 29. Let me take this kind of data and let me show you by drawing a histogram how this data can be spreaded. So there is a concept in these histograms called as bins. So after drawing the diagram here, I will explain you while drawing the diagram what are these bins. And for example, for suppose let us take the number of bins as 6. That means we will have 6 boxes here. So in future we can draw 6 boxes here. So I'm marking stars where I want to draw boxes. So I have drawn 6 boxes, and let us see the data here. Here we have data from 1 to 29. That means, for example, we have data from 1 to 29, which is almost equal to 30. So I'm taking my bins as 6. So I will divide this 30 by 6. So now I will get my answer as 5. That means for each of the every 5 data points, I'm going to consider those data points into one bin. So for this, what I can do is that for 1 to 5 data, I may consider it as one bin. And from 6 to 10, I may consider it as one bin. And from 11 to 15, I may consider it as one thing. And from 16 to 20, I may consider it as one thing. Here the data is unavailable. And from 21 to 25, I will consider it as another thing. And from 26 to 30, I will consider it as another bin. So first of all, I will write the y-axis names here. So 1, 2, 3, 4. And this is x-axis and this is y-axis. So now first of all, find out how many numbers were there between 1 to 5. So here there are 3 numbers, 1, 2, and 4. So I will draw a box here which represents that there were 3 elements between 1 to 5. So this is one bin which ranges from 1 to 5 numbers. So after finishing of this, now go to next bin. So here we have 7 and 9 between 6 and 10. So that means we have 2 data. So I may draw my histogram bin as like this. And after that, from 11 to 15 also, we have two data. So I will draw my third bin also like this. From 16 to 20, we have no bins. That means the bins were missing. So I'll keep this as empty. And next we have three elements from 21 to 25. So I may draw a box like this. And then from 26 to 30, I have only one element. So I'll draw my box like this. So finally here, I have drawn all the bins. So each of the box which we are seeing here is bin. So for that example only, I have taken 6 bins. So actually 6 bins should be appeared here. But what happens is that here the data is missing between 16 to 20. So that this bin is not visible to us, but internally it will consider this also as a bin. So this is the bin, and while someone gives you data in the form of this data X, it is may not be possible to us to understand how this data is spreaded. But while seeing this diagram, one can easily say that, okay, in the first bin there are 3 number of elements, in the second bin there were 2 elements, and in the third bin there were 2 elements, and here from 16 to 20 there is no element present. So easily the users can see the diagram and can represent it. And furtherly, there is one more concept in this histogram only, that is called as smoothing the curves. That means we can smoothen the curves, something like this. So basically my data would be started here. So it is going like this, and again it is coming downwards, and then here it's coming very down, and again it is improving its range, and again coming down. So this is called smoothing of the histogram. So this is called the smoothing of the histogram, the process of drawing this line based on the given histogram. And also we can call this curve something as PDF, which means probability density function or probability distribution function. So this is all about histogram, and now let me show you about the skewness of data. So in the skewness of data, we will use something called as smoothing of data, which we have seen before after drawing the histogram. So now let me tell you about skewness of data. So I will talk about skewness of data now. For example, let us consider a distribution like this. So maybe this will be my mean. What we can observe is that this distribution is similar to the kind of bell symbol. So that's why we may also call this as bell curve. And in this example, there is no skewness. Also, in the bell curves, there is no skewness, and mean and median and mode will be ranged in the same area. That means this area. Okay, this is the example of no skewness. But now let us dive into skewness. In skewness, we have two skewness. One is right, which is also called as positive skewness, and also there is one thing called as left skewness, which is also called as negative skewness. So let me draw first about right skewness. So right skewness could be something which is like, it is similar to bell curve up to this point, but from here the distribution would be spreaded more towards right. Or we can say that the distribution is bended mostly towards right side, so that's why it is called as positive skewness or right skewness. So in this right skewness, what is going to be happened is this point is going to be my mode, because most of my data ranges between these area, and this area might be going to be my mean, because although highest number of data is here, most of the data was spreaded in this region, so that's why it can easily overcome this data and it can easily become the mean of the whole distribution, and the median could be ranged somewhere like this. So I will tell you why this is happening, because let us consider that some data like 0, 1, 2, 3, 4, 5, 6. So this is going to be 6, etc. So as the data is like this, when we draw the bins using histogram, so this 3 might be here, which might be some value which is greater than all the below values, and it is highest point of this distribution. So as we know that mode is nothing but highest number of elements, so that's why this is going to be mode, and this is mean, because maybe we can think that here the distribution could be something like 2 data points. So here we have value as 6. 6 plus 6 is going to be 12, and 12 by 2, which is going to be 6. So we may have mean something as 6, but here we have the data as 3, but consider that we are having the number of distributions here as 3. So then when we calculate the mean of this area, what will happen is 3 plus 3 plus 3, because we have 3 data of number 3, which is going to be divided by 3. So obviously we will get 3, but here we got as 6. So what we can tell from this is, in the right skewness of data or positive skewness of data, my mean will always be greater than my median, which is always be greater than my mode. So here my mean will always be greater than my median, and my median will always be greater than my mode in the positive skewness or right skewness. So after discussing right skewness, we may also discuss about another thing called as left skewness. So in right skewness, we have discussed that the bend is more towards right side, but in left skewness, the bend will be more towards right side, and the distribution might be like this. And as similar to it, we will have the mode here, and we may have median somewhat here, and we may have mean here. So in right skewness, mean is always greater than median, is always greater than mode, but here mode is always greater than median, and this median is always greater than mean. So this is all about left skewness, and as like we were calling right skewness as positive skewness, we also can call left skewness as negative skewness. So this is all about histograms and left skewness and right skewness. In the upcoming videos, we may discuss about different types of distributions, and we may find out the probabilities of getting that distribution, and we also can find mean, variance, and standard deviations of that particular distributions. So this is all about today's video. If you like the video, I would highly recommend you to subscribe to my channel and like the video. And also don't forget to watch the playlist which I have created and updated it on the description box for you. So In that playlist, you can learn about different concepts of statistics for data science, where you can learn from very beginning level to the very high levels of statistics for data science. So this is all about today. Thanking you and goodbye. Let us meet in next video.